The second file is almost a step-by-step guidelines about how to set up a new point counting project in the JMicroVision software. So there is a link here for you to download the software on your computer, and then hopefully you can follow all the steps to set up your project. So instead of going through that guideline, I'd rather go into the software itself. So let's see if I can do it again. I'm gonna close this one here. All right, and I'm gonna say that I want to start a new project from an image. So the software is gonna ask me to find the image. And so I recommend you to create a folder, maybe on the desktop of your computer, where you will store the scanned thin sections as well as the GMV files that are the project files. So I'm gonna open, for instance, this RI2X file. So the software asks if you want to optimize the image, so resize it. I'm gonna say yes. And so it's asking me to save it as a TIFF image. I'm gonna say yes. So I'm gonna erase the other version that I had on my desktop. And so that's the scanned thin section. I'm gonna zoom out a bit. Okay, so you have a hand tool at the top left that you can use to move into the thin section, and you can see there is a little thumbnail here. You see here on the right-hand side, there is a notch, and the notch that Jacob did in the sample corresponds to the upper direction within the bed, meaning that this is the stratigraphic top of the bed, okay? And so you also have a scale here. Now to start the point counting, you have to select in this drop-down menu point counting. And here you see under class, there is nothing. And we need to have some classes. The classes correspond to the grain types or the components in the rock sample that you want to count. So to populate that field, you can click on class editor and click on add list. And this is now that you're going to select this PCL file that I shared with you in OneDrive. And in there, you have all the potential grains. I hope I captured all the grains you could find in those thin sections. Okay, when it's done, you can just close that window and the grains are here now. Okay, so that's pretty handy, I would say. Okay, so now to start the point counting itself, you just have to click on, well, click on start. But before doing that, I'm going to save the project. So it's going to be saved as a GMV file on your internship folder. And make sure you're saving that from time to time. Whenever each thin section will be counted, we would like you to upload that GMV folder back to OneDrive, to my folder. All right, so now that it's saved, I can start the point counting. The software is asking me to specify some parameters. So for the grid type, I recommend you use a random grid so that the software will move within the thin section. If the target falls into the glass slide, we can skip the points, the locations. Then under counting limitation, you can leave under no limit, but just put an alert at 250 points. That's your target. Count 250 locations within the thin sections. That would give us a very good idea of what's happening in those samples. And for the area, you want to use the whole image. Now that that's done, you can click on OK. And you see directly the session starts. I have the target that moved into a location here. So it's a bit, okay, I need to zoom in a bit. So I'm going to zoom in a bit. Okay, in that location, what I can see here, and it's not easy. It's a small grain here that I can see behind, and I think that's a crinoid remain. So I'm going to go down the list here, and you see I can either click on crinoid, but I can also hit the 6 key on my keyboard. And I don't know if you've seen, but well, you haven't, but here the software is displaying how many points I have counted. So now I've counted 1 point. Second location, it's in the shadow, it's outside the sample. I don't want to count that. I'm not interested into that. So I can click on that key here to move to another location. I'm back into the sample. I think I'm looking at some micrite here, some matrix. So I'm going down, and I think it's the E key. Yeah, okay. All right, and that's the same. So you're gonna probably count a lot of matrix. Okay, now I'm falling in one of those large triangular shape. That's a benthic foraminifera. That's actually an orbital in it. So I need to go back up and find orbital in it. Okay, so it's a bit cumbersome to move up and down. You can also click on floating window here and increase that so that you see a bit bigger your list of class. And if you're interested in seeing what's happening in your data set as you count, you can click on evolution plot. Okay, and so now if I go a bit faster, okay, that's an orbital in it here. So that's 2, that's probably a 2, that's a he, that's a skip. So I don't know if you see on the right-hand side, but the curves are evolving, okay? And I can see that the majority of the sample right now is dominated by the pink color that is the matrix. I'm gonna skip that. And so you need to, we would be glad if you can do that for 250 points. And I know when you will start, it will take you some time to get to learn the grains, but after a couple of intersections, you will become masters. You're mastering that technique, okay? Whenever you will be done, you will save the project with all the point counting done on that sample. And upload it back to the OneDrive folder I gave you access to. And I would also ask you, I'm going to close that up, to click on, I think this is that icon here, the data viewer, sorry, and export the data as a CSV file so that we will have your raw data in a way that we can further manipulate afterward. Okay, so that's how it works. That's how it works. It's not, I don't know, that complicated. Let's see, what am I missing here?